Welcome to the final video in my cameras and resolution tutorial series. At this point, we are in the deep end. Beyond this point, there are no perfect solutions. There are no correct answers. There are no foolproof processes or procedures. We have entered the realm of opinions and best guesses. I'll show you how to do a couple of things, but this is much less tutorial and much more GDC talk. If your game isn't pixel art, the vast majority of this video really isn't going to apply to you. You've decided to play on easy mode, and you don't need to worry nearly as much about how your game stretches and scales to different screens. Congratulations. But if you are among the many out there building a pixel art game with grave concerns about how it will look on different monitors at different resolutions, well, let's talk about that. Before we cross the threshold into truly dark waters, I want to take a moment to talk about the GUI events. The GUI events are sort of weird. We often say GUI layer, but that isn't quite right. There is no layer. There isn't even a surface. Everything that is drawn in your GUI events is drawn essentially directly to the game window. The GUI size simply determines the scale at which everything draws. So if your window size is 500 by 500 and you've set your GUI size to 100 by 100, when you draw something, it's going to automatically draw everything scaled up by 5 times. Let's run the game and take a look at something real fast. So our window size is currently 1600 by 900, but look at the scale of our GUI right now. It's 5x. So what would happen if I went into Object Player, added a Draw GUI event, and drew the player sprite in there? When we run the game, we can see we have a copy of our character sprite just hanging out at the bottom. He's the exact same size as what we draw by default in the normal draw event. This is typical of a pixel art game. You size your GUI to match your view, and your UI has a consistent pixel density. You can break this rule though. A game like Celeste has a much larger GUI size than view size. This works well because the UI has a completely different art style than the game in the background. It looks fantastic, but needs to be done carefully. However, if you do that, keep in mind that your minimum window scale is no longer 1. It's now whatever the scale of your GUI is. Real quick, let me show you something interesting about the GUI. Let's go back to the code and change the draw sprite to a draw sprite extended and draw our character scaled down to 1/5 its normal size. Would you look at that? He's perfect. He's small, yes, but he hasn't lost a single pixel of detail. Now you might be looking at the display info up there in the corner and saying, yeah, but that's because you have subpixels enabled. Your app surface is high res, so you could do this exact same thing in the draw event. You are half correct. I do have subpixels enabled, and this would currently work in the normal draw event. But even if I turned them off and the app surface was sized to be the same size as the view, this would still work. That's because you cannot turn off subpixels for the GUI. It's not possible by default. So if you are trying to stick to a strict retro pixel grid, you can use the GUI events, but just be careful not to do any scaling or rotation in your UI, or the illusion of your aesthetic may crack. We can't talk about making a game in GameMaker without mentioning Undertale, can we? If you've played Undertale on PS4 or 5, you may have noticed that the game looks a bit different. Why might that be? Well, Undertale's default resolution is 640 by 480, and consoles are typically played on TVs. TVs are very typically 1920 by 1080. Obviously, Undertale isn't widescreen, so let's just divide those heights real quick. 1080 divided by 480 is 2.25. Not a whole number, not going to scale perfectly. This is what Undertale looks like in full screen on 1920 by 1080 monitor on PC. I've overlaid a grid just to show you what a mess it is. Does it look fine? Yes, of course. I'm sure many people on PC played the game full screen at 1080p and didn't complain. Undertale's art style just sort of works, even when things are a bit messed up. But when it came to the PS4, someone, apparently, didn't think it looked good enough and decided the whole game needed to be rendered in a box. This allowed the game to scale perfectly up to 2x to 1280 by 960. Maybe you want to do something similar. If your game doesn't scale perfectly to the current monitor, you'd rather display your game in a black box that is perfectly scaled than fill the whole window as much as you can. How would you do that? Let's go back to our sample project and change the base size to 640 by 480. Then, let's jump over to our check toggle full screen function. We just need to add a line here to disable the automatic drawing of the application surface when swapping to full screen, and bring it back in windowed mode. If we ran the game now and swapped to full screen, we wouldn't see our game. Disabling the automatic drawing of the app surface means that we need to manually draw it to the window. Let's add a post-draw event. At the top, once again, we'll make sure we are in full screen, and if we aren't, just get out. Otherwise, we are going to draw the application surface. The post-draw event is sort of a weird one. The coordinate system here is the game window. So 0, 0 is going to be the very top left of our game window, including any black bars. So we have to use the window dimensions to position our app surface centered on the window. We already scale our app surface appropriately, so we don't have to really do anything else. Now let's run and see how that looks. Yay! It's perfectly scaled, and it's in a box. We can even draw a background image or a color behind it if we wanted. But you might be noticing something strange. In fact, there are two issues. One we can easily fix, and one we can't. Look at the shadow underneath the bushes. As I toggle between window and full screen, are they getting darker in full screen? That's weird, right? This is something we have to contend with when we are manually drawing our application surface. It's how pixels in a surface that are semi-transparent blend with the drawing target, the window. It's easy to fix, but honestly a bit difficult for me to explain. So we're just going to fix it and move on. I bet there's some nerd in the comments who will explain it better than I can anyway. Above where we draw our app surface, we just add GPU set blend enable false. And then below it, reset it back to true. Let's run again and toggle between full screen and windowed mode. There we go. That looks good. So that's one problem down. But what's up with our display info? It's not in the top left corner of the game anymore. It's floating above it. What's going on? This is one of the problems with drawing your game in a box. The GUI event draws based on where GameMaker normally draws the application surface. So when you say, no, I'm going to draw it where I want to draw it, there's no way to tell GameMaker that you are drawing it somewhere else. So the GUI isn't going to line up with your new game in a box. Unfortunately, that's not the only thing that breaks. If you're planning on using mouse interactions in your game, mouse X and mouse Y functions will also stop working. So if you want to draw your game in a box and use built-in mouse functions, you're pretty much out of luck. Along those same lines, some people want to emulate old school RPGs where the game's UI is off to one side and the game itself renders in some sort of frame. This is going to have the same problems. Anytime you want to manually draw the application surface somewhere besides where GM would automatically draw it, you break the GUI, you break mouse interaction, you break UI layers. One possible solution is to build your game as I've described in the previous videos, with the app surface drawing normally and automatically, and then just draw the UI on top of everything as a mask. So your camera is technically showing more than you really want, but you use the GUI to hide what you don't want to show. Then you just adjust what it means for your camera to be centered on something. All that being said, I have submitted a formal feature request to allow us to define the rectangle the application surface, mouse variables, UI layer, and GUI all use to align themselves. So if we get that at some point in the future, you can bet I'll release a new tutorial to show you how to use it to do this. In the meantime, I tend to recommend against it. Maybe I've talked you out of drawing your game in a box, but you still aren't happy with how your game looks in full screen on some displays. That's totally understandable. While I think in the vast majority of cases, it's probably going to be alright, if you still want to make your game look just a bit better, there is an option. Let's look at an example. You may have heard of a little game called Sonic Mania. It's a game that leans heavily into its authentic retro pixel art aesthetic. It aims to look like an old Sega Genesis game, and it has received unanimous praise for those visuals. But are they perfect? Sonic Mania's native resolution is 424 by 240. Let's go ahead and divide 1080 by 240 and we get 4.5. Not a whole number, not perfect scaling. So how did Sonic Mania get universal praise for its pixel art visuals while not perfectly scaling to the most common display resolution in existence? Bilinear filtering. Bilinear filtering is a method of upscaling pixel art more carefully. It's a super common upscaling method, and there are a ton of resources out there that can give you a more accurate technical explanation of how it actually works. Me, I'm more concerned with the results, and as you can see, the results are impressive. When zoomed out at full res, in most cases, it's nearly impossible to see that any blurring is happening at all. Everything looks crisp. Add in 60 FPS motion to that equation, and no casual player is ever going to notice. Of course, this depends on the scale factor. 4.5x probably would look fine in motion at 60 FPS to begin with. Once you get over like 3x, any distortion is going to be super minor in almost any game, let alone a fast-paced game like Sonic. But if that was 1.5x or 2.5x, the result might not be as clean. So if you make your game at a cursed resolution like 1280 by 720, I'm not positive even a bilinear filter will save you. Okay, how do we do this? Let's start from the same point Sonic does. Let's go change our base size to 424 by 240. When we run the game and swap to full screen, we are still running in a box because, as we just mapped out, this resolution doesn't scale perfectly to 1080p. Since we are going to be drawing the application surface to the screen with a shader, we still want to turn off the automatic drawing of the application surface in full screen. To save us from having to do more math, we're going to change the event we draw the application surface in from the post-draw event to the draw GUI begin event. That will let us take advantage of the fact that even when the app surface isn't being drawn automatically, the GUI is still positioned in the window where the app surface should be drawn. We are going to need a shader. I'm not going to write a shader for the sake of this tutorial. I've already got one. It was originally part of a marketplace asset that, by the time you're seeing this, may or may not still be available. It's written by Mytino for his better scaling asset, and I got his permission to repackage it as part of an open source tool I've been working on, which we'll talk about later. But for now, we're going to grab the shader out of that project's GitHub and just drop it in this project. Okay, we got our shader. So in the draw GUI begin event, we still don't want to do anything if we aren't in full screen, so keep that logic. But before we draw the application surface, we need to set the 4 uniforms for it to work properly. The bitmap uniforms are referring to the surface we are going to draw. In this case, the app surface. So we'll just pass in our app surface width and height. The scale uniforms are pretty self-explanatory. We just need to pass in the ratio of our window to our app surface. So we'll calculate that up above and plug it in. Finally, we just draw our app surface before resetting the shader. Since we are in the GUI event, we can just draw the app surface stretch to fill the GUI dimensions, and everything should look good. And yes, we still need those blend enable toggles. If you have an unusual setup, you may need to think a bit harder about this logic, but for this project, and I expect most projects, it's just this simple. Let's run again and swap to full screen. And yeah, it looks pretty great. I'll be the first to admit that the art I'm using for this example project isn't exactly ideal for demonstrating how good this looks. A project that has more detailed pixel art will benefit much more from a bilinear filter, as we saw with Sonic Mania. So I'd advise waiting until you have a visual issue you want to try and smooth out before you go to the trouble of setting this up. As I mentioned a moment ago, I'm working on an open source library that tries to do all this for you automatically. It's called Keystone, and as of recording, it's still pretty early in development. There's no documentation, and it's definitely not thoroughly tested yet. Just an example project and a package you can bring into your project. It supports bilinear filtering and drawing your game in a box, but with tools to deal with the features that are broken like mouse support and misaligned GUI. It does not work with UI layers, however. And if we ever get that feature request I mentioned earlier, I could probably reduce the amount of code in this system by 75%. So check it out if you want, but I just wanted to shout it out as an option. There's a link in the description below. Finally, it's time to talk about stuff that is maybe a bit controversial. Let's talk about scaling perfectly to any display resolution without using any sort of shader cheat code, aka pixel perfect scaling with dynamic aspect ratio support. You may have seen my very old tutorial series, Resolution and Aspect Ratio Management, where I claim to have a simple mathematical process to scale your pixel art game perfectly to any monitor resolution. So in theory, when your game is ran on any screen, it renders with no black bars and spot-on pixel perfect scaling, zero distortion. The process described in that video is flawed. It doesn't work for all resolutions. What's funny about this is that it didn't even work for a laptop I had around the time I made those tutorials. Let's walk through the process described in that video real quick and dunk on my past self. In that tutorial, I was working with a widescreen SNES resolution as my base size, 512 by 288. Let's see how the math I do in the tutorial works when the monitor resolution is the same as my Surface Book 2, 3000 by 2000. 3000 divided by 512 equals 5.859375. We round that up to 6, since it's the smallest change to my desired size. Then divide our display's horizontal resolution to get our view width. 3000 divided by 6 equals 500. My view width should be 500. So far, so good. Now we just divide the display's vertical resolution by 6 to get my view height. 2000 divided by 6 is 333.3333 repeating. Not a whole number, not going to perfectly scale. Sorry. And you might be saying, maybe there's another solution. And maybe there is. But let me show you one more problem I ran into about 4 years ago while trying to find a better solution that convinced me to just stop trying to support dynamic aspect ratios and every monitor resolution that could exist for my 2D pixel art project. The bottom line is, for pixel perfect scaling with no black bars, you need to be able to find a view size that is a whole number multiple of the monitor resolution, which means you divide the monitor resolution by the view size and you get a whole number, like 2, 3, 4, etc. I present to you my cell phone, the OnePlus 8. Now, the spec sheet says the landscape resolution of the phone is 2400 by 1080. But when I use display get width from GameMaker to ask for the display resolution, I get a display width of 2297, 2297. That's a prime number. You cannot divide that number by anything but itself and 1 and get a whole number. There is no way to scale any pixel art game to that resolution perfectly. It's literally impossible. Why would it report 2297 when the resolution should be 2400? No idea. I spoke with Russell Kay, the head of GameMaker, and he theorized it could be a funky DPI thing, a safe draw zone, or some other Android-specific thing. But there really isn't anything GM can do here. If Android tells GameMaker the resolution is a prime number, we have to use it. It really made me reevaluate how important this is. In a 3D game, supporting any resolution and any aspect ratio is so simple. You just change your camera aspect ratio and your internal resolution. Even if it's not scaled perfectly, who cares? Nobody's going to notice. But for a 2D pixel art game, if it takes so much work, is the effort worth it? Are there reviews of great pixel art games where people are complaining about it not filling out their ultra-wide? If so, are those people worth pleasing? Ultimately, if you've made a good game, people are going to be too busy enjoying it to worry about the black bars or minor pixel distortion. And if your game is popular enough that there's a small subset of your player base begging for ultra-wide support, man, what a great problem to have. That's why my current approach is to design for 1920 by 1080 and just not worry about anything else until I have a real paying customer begging me for changes. You should really ask yourself, would Undertale have sold better if it had ultra-wide support? Wow, you made it to the end. Hopefully you learned something useful. Otherwise, this was sort of a huge waste of time and effort on my part, wasn't it? If you do have questions, just want to get help with GameMaker, or even just hang out with other GameMaker users and talk shop, I recommend joining the GameMaker Discord server. I put a link in the description. Thanks for watching. Now go make something awesome.